Hi, Mr. Hanny here. In this video we're going to be extending our understanding of trigonometry to this thing called the unit circle. So over here I've drawn a unit circle. You can tell it's a unit circle because it's got a radius of 1. So it goes here to 1, and 1, minus 1, minus 1. And just to make our lives a little bit easier, we want to describe these different quarters of this unit circle. So we give them each different quadrant names. Quadrants. So this one here we'll call quadrant 1, where both x and y are positive. Over here this will be quadrant 2, where x is negative but y is positive. Quadrant 2. This one we'll call it quadrant 3, and this one over here quadrant 4. Now the reason it goes 1, 2, 3, 4 in that order is that angles are measured going up from this way. So there's an angle. If the line was coming out this way, this angle would be measured there. Or imagine if the line was coming out this way, its angle would start here at the positive x-axis and come around and be measured the whole way around there. So that's why the order of the quadrants goes that way. Okay. Now what I'm going to do with my unit circle is I'm going to draw a right angled triangle inside of it. So there we go. And that is a right angled triangle. Now obviously here the radius is 1. So that means this hypotenuse length of our triangle must be 1. And here is our angle. Measuring around in that direction is our angle. And so here, if we remember that that sine of the angle is equal to the opposite side over the hypotenuse, but here the hypotenuse is 1. So if the hypotenuse is 1, that's opposite over 1, which just equals the opposite side, this opposite side. Now the opposite side you can read off the y-axis. That's here, the opposite side, you read off the y-axis. So, so we say that the y, if you read off y, that is, y is sine of my angle. And similar for the adjacent side, we can say that we remember that cosine of the angle is the adjacent divided by the hypotenuse. But the hypotenuse is 1, so we've got adjacent over 1, and that just equals the adjacent side. Now the adjacent side here is read off the x-axis for the adjacent side, for the length of the adjacent side. So that means what we can say is that the x-axis is cosine of the angle. So the x-axis along here, that's cosine of the angle. You can read it off there. And the y-axis is sine of the angle. So that's the first thing. Also, tan. So tan. Remember I said that tan really means tangent? Well, if we draw another, like a tangent line's a line that just touches something. So here it only just touches the unit circle. This is my tangent line. Tangent line. So imagine if we continued this upwards, it would hit. So by the way, this here is roughly, as I've drawn it, it's roughly a 45-degree angle. So that's, as I've drawn it, that's 45 degrees, or pi on 4 radians. This angle roughly that I've drawn, just to keep that in mind. So here, if you go up to tan, keep going to the tan line, here you see that it hits at around about 1 on the tangent line. So here tan of 45 is 1, and that is actually true. So tan you can read off, tan of the angle, you can read off this tangent line here that we've drawn in. So we now have an alternative definition for sine, cos and tan, all based around the unit circle. So sine is y-axis, cos, x-axis, tan is whatever the tangent line is. So here, if you want to find sine of 45, well, you can read off the y-axis. Here, it's some value here, which is roughly, extremely roughly, 0.75. And similar for cosine of 45 degrees, it's very, very roughly 0.75. So those aren't the exact values because my circle is not a perfect circle. If I did this same, and this is not perfectly 45 degrees. But if you did a perfect 45 degree angle and a perfect circle, then you would get the exact answer. Okay, so that's all pretty easy when our line's in the first quadrant. So we're in the first quadrant here. How is that helpful in other places? So why do we bother with this new unit circle definition? What was wrong with our right angled triangle definition that we all understand? Well, there's a few advantages to this unit circle definition. One of them is, what if your angle is equal to 0? So you've got a 0 degree angle. That means it's just coming straight along this x-axis here. It's coming straight there, right to here. Now you can't have a triangle with a 0 degree angle. Like, it just doesn't make sense. That's just a line. See, this is not a triangle, this line, it's just a line. But here we can say that cosine of 0, well, that's the x-axis, so that must be 1. And sine of 0, well, that's the y-axis here, so sine of 0 is 0. That's the y-axis point here. You can do the same thing for if our angle goes right up vertically, that is a pi on 2 radian angle, also known as 90 degrees. So if you do a 90 degree angle, you can't have a triangle that's got two 90 degree angles. Doesn't make sense. But here you can do it. If we have an angle of pi on 2 radians, so it gets us right to this point here. Well, our cosine of pi on 2 radians, that's the x-axis, so that's 0, and sine of pi on 2 radians, well, that's the y-axis, so that's 1. Pretty handy. Now, the next strength is, it used to not make sense to have a right-angled triangle that had a negative angle, that had like larger than 90 degree angles in it. So imagine we had, let's try a slightly different angle, this one here. So let's say that this bit here is 30 degrees, which is the same thing as saying pi on 6, but angles are measured from here all the way around to that. So that angle is 180 degrees minus 30 degrees. So in other words, that angle is 150 degrees. Or another way of thinking about it is it's pi minus pi on 6. In other words, that is now 5 pi on 6. This angle that we've looked at here. So if we do some of these. Okay, so for this big angle here, what we've got to do is we've got to measure it for this bit here. So that is cosine of 5 pi on 6. That be there. And however high it is on the y-axis over here, whatever value that is going to be sine 5 pi on 6. That's 5 pi on 6 there. Okay, so you can also do these other angles that previously didn't make sense. Now obviously here, for the cosine 5 pi on 6, it's going to be negative. Okay, it's going to be negative. But the sine 5 pi on 6 is going to be positive. It's going to be positive there. Also, you might be wondering what happens with tan. Well, if you keep this coming, if you sort of dot it out until you hit the tangent line, then that is your tan value. So the tan value here is negative as well. So in quadrant 2, sine is positive, cos is negative, and tan is negative. So we're going to say this quadrant here, we'll call that like the sine quadrant. It's sine is positive in this quadrant, quadrant 2. In quadrant 1, all of them I'm going to write a bit of an A for all of them are positive in this quadrant. Now if we check out this quadrant here, imagine we have some angle, doesn't matter what it is, going all the way around to here. So now from our x-axis, so cosine, the cosine bit from our x-axis is going to be, so along our x-axis, the cosine bit is negative now, you see on the x-axis is negative. The sine bit from the y-axis, that's negative as well. But the tan bit, if we keep extending this up, and we're going to go off the screen here until, just keep going up and up and up on that same angle until we hit the tangent line. So you're going to see that that's going to be a large number for this angle I've drawn in here. This big angle all the way around. So you can see that tan is positive, but the other ones are not. So this I'll label as a T for the tan. And then let's do an angle here somewhere. Let's do one down here. There you go. So this angle is coming from the x-axis all the way around to here. That angle. Now, here, the x-axis amount, so that's the cosine. The x-axis is positive, y-axis negative, and if we continue this on, it'll keep going down at this angle till it hits the tangent line. So tan is negative. So here the only one that's positive is cosine. So we've got all of them are positive, sine is positive, tan is positive, and cosine is positive here. Alrighty, I think we need to, at this point, summarize some of our knowledge, and then we'll continue on. So let me summarize a couple of things. So now we know if we have a unit circle, so we're using a unit circle, we know that x is cosine of the angle, y is sine of the angle, and the tangent line value equals tan of the angle. We also know, I'm just going to draw a mini one. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Here's our circle. So here we know that all are positive. In quadrant 2, sine's positive. Quadrant 3, tan, and quadrant 4, cosine. So here's sort of where we're at. We're using unit circle to find our angles. We also know that you need to measure going up. Okay, let's learn a couple of extra things now. Let me just create a new unit circle. Okay, so let's take, here's a new unit circle. Let's take an angle of 30 degrees. So 30 degrees, also known as pi on 6. And it'll give us the cosine value along here. Cosine pi on 6. And sine pi on 6 will be the y value. Okay, so we've got the two values, the y value and the x value. Cosine for the x, sine for the y. Okay, now suppose we took this other angle out in this direction, so that if this bit here is the same, it's also pi on 6. That means going from here all the way around is 5 pi on 6. 5 pi on 6. That's because the full 180 degrees is pi. Full 180 degrees is pi. And so if you take away pi on 6 from pi, we get 5 pi on 6. So this angle is 5 pi on 6. Now, hopefully you can see that this is sort of a symmetrical thing going on here. So here we've got, if we go down, so here our cosine value is going to be negative of this cosine value, because it's the same distance, but it's negative. So cosine cos 5 pi on 6 equals negative cos pi on 6. Okay, now that's not surprising because remember this is the sine quadrant. But what's interesting is that it's negative, but it's the same value for cos. It's the same value, but negative, because this bit here is pi on 6. Now, for this, for the y-coordinate, however, the sine, so sine of pi on, sine of 5 pi on 6, that is the exact same coordinate as sine of pi on 6. That equals sine pi on 6. So, because this is the sine quadrant, the sine values are positive and exactly the same, and the cosine values are the same number but a negative value. So that's quite interesting. And suppose we did another example. Suppose now that we took a 45-degree angle, so that one's pi on 4, and now we did one down in this quadrant. So this is now going to be, see, pi on 4 gets us there, 2 pi on 4, 3 pi on 4 gets us halfway, 4 pi on 4, 5 pi on 4, 5 pi on 4. Or another way to think about it, just this bit here is pi on 4, and we start at pi, and we go a little bit more to 5 pi on 4. Okay, so here we've got this value here compared to this one here. Now you notice that if we go up, the tangent value is going to be the same. Our tangent value is the same here, exactly the same, and our sine value is the same but negative, and our cosine value is the same but negative. So this is our tan quadrant. So you can see using symmetry how we can find some different angles just using symmetry. Same thing is going to happen in this quadrant, but this is the cosine quadrant. So perhaps the simplest way from here is to just do a couple of examples of this sort of thing. So let's say find cosine of 3 pi on 4. Okay, so what I've got to do here is go, where is 3 pi on 4 on my unit circle? So here's my unit circle. Where's 3 pi on 4? Well, that's just a little bit short of 1 whole pi. So 1 whole pi is over here, and it's pi on 4 short. So it's over here, and this bit here is going to be pi on 4. Pi on 4. Which means this, in this quadrant, only sine is positive. So because that's pi on 4, if there was another bit over here that's pi on 4, we know that the cosine is going to be negative. So cosine 3 pi on 4 equals negative cosine pi on 4. Okay, so that is a good thing. Now let's try another one. Find tangent of 4 pi on 3. Okay, so 4 pi on 3, we've got to find that on the unit circle. 4 pi on 3, that's larger than a pi, and it's larger by pi on 3. So it's out here, where this bit here is pi on 3. So because this bit here is pi on 3, and because this is our tan quadrant, this is just going to be the same as positive tan pi on 3. Okay, so hopefully that makes a bit of sense to you. So really what we're doing, once you find the angle, so here's sort of like the base angle that we want to measure. If it turns out our angle's over here, what we're interested in is actually this bit of the angle there. Similarly, if it actually extends all the way to here, there. This is the bit that we're interested in, just that bit there. And similarly, if our line's over here, we're interested in this angle in there, even if we're looking all the way around there. Okay, one last handy thing is knowing that unit circles. Let's see. If we have a unit circle, you can actually, like if we're looking for the angle of say 700 degrees, that's like going around, that's 360 so far. Then we can do, so we've done 360 so far, 360, so we need to do another 340. So we've done 360 and we'll go around another 340, gets us here. Now that gives us another, there's 20 degrees in there. Okay, so if our question said something like, find a first quadrant. Find a first quadrant equivalent to I don't know, to cos of 550 degrees. So here I'm using degrees. Find a first quadrant equivalent to cos of 550. Well, I know that that's going to go, that's more than 360. So it's going to do a full loop. So it does a full loop, which takes out 360 degrees of it. So that must equal the same as cos. Then I'll take out 360 degrees because I've done a full loop and gone back to exactly where I was before. So that is leaving us with 190 degrees left over after I've taken out my 360. So it's cos of 190 degrees. Now let's find cos of 190 degrees on our unit circle. 190, so here's 180 over here, 180, a little bit more for 190, 10 degrees more. So this little sliver is 10 degrees, and we're in quadrant 3. Quadrant 3, only tan is positive, so the answer is negative cosine of 10 degrees. Because this little sliver is 10 degrees, so it's cosine 10. Cos is not positive in the third quadrant, so we've got the negative sign. Okay, let's do one more of a similar type. So again, find first quadrant equivalent to, okay, this time I'll do sine of 765 degrees. Actually, you know what? I'll do this one as a radians one. Okay, so a radian one, I'll do okay, 29 pi on 6. Okay, now first I'm thinking, well, how many, well, this is in improper sort of fraction situation here, so let's see how many pi's there are, full pi's there are in here. So I noticed that there's 24 pi plus another, so that is sine of 29 we can break up into 24 pi on 6 plus another 5 pi on 6. So here this bit, I took out 24 because I knew that 24 on 6, I can change that. I'll do it here. 24 pi on 6 is just 4 pi, then plus our 5 pi on 6. So 4 pi is 2 lots of 2 pi. So remember that an angle that's the whole way around is 2 pi. So this angle is going around, starting here, and it's going around, there's once 2 pi, 4 pi, so it's going around 4 pi, and then another 5 pi on 6. So 5 pi on 6 is almost another pi, but not quite. So this is our angle coming off here. And so 5 pi on 6 is 5 pi on 6 is pi on 6 less than a whole pi. So this angle here is pi on 6. So what we're dealing with here is the same as sine 5 pi on 6, which, as I just mentioned, is an angle out like this, where this bit here is pi on 6. So that's the same as sine pi on 6. Now if you've decided is it positive or negative, we notice that this is quadrant 2, and that's the sine quadrant, so it's positive. So it's equal to positive sine pi on 6. So there we go, and I think I'll leave that video there. In the next video, I'm just going to do more and more examples of using the unit circle to do trigonometry things. Okay, thank you, and see you later.